All right, in this video, we're going to talk about similar figures. We're going to throw in some scale factor, some similarity statements. Some of what we are going to look at today, you are going to recognize from congruent triangles. So let's start with some vocab. So polygons with the same shape, but different sizes are what are similar. Okay? So they have the same shape, but different sizes. Dilations is one that comes to mind. Polygons are similar if their corresponding angles are congruent. So corresponding angles are congruent. So meaning that they're equal. Ooh, got my T in there. And then they would have corresponding sides, because if they were congruent, then they'd be exactly the same. They would not be similar, they'd be congruent. But our corresponding sides would be proportional. So corresponding sides, proportional. And you're going to notice that we're just setting up ratios for these. So the ratio of the corresponding sides is called the scale factor. We've done scale factor. We've set it up many different ways. We've used it different ways. If polygons are similar, then their perimeters, okay, their perimeters, meaning add up all the sides, are going to be also proportional. So let's go ahead and take a look at the scale factor. So what's the scale factor of triangle ABC to DEF? So before we do that, I want to go ahead and review kind of how the angles are marked and matched. So remember that angle A and angle D are congruent. Angle B and angle E are congruent. And then angle C and angle F are congruent, just as they're marked here. We did this in congruent right before end of semester. Now, instead of the sides being congruent here, they are going to be proportional. So we'll take a look and see which sides are proportional. Okay, so now when matching up the sides, it's very similar. The sides are not going to be the same, but they are similar. They're proportional, meaning the scale factor will be the same for each. So AB and DE correspond to each other. This is we've done before. And then if you look at BC and EF, so second and third, and then the first and third AC and DF. Those are corresponding sides. Now let's go ahead and take a look at what our scale factor would be. So you can pick any two that you wish. I'm going to go with the green ones. So we're going to go from triangle ABC to triangle DEF. So it's going to be 8 over 12. I'm going to take the green sides that match here. Then I'm going to simplify it. Equal. So if I simplify it, divide both by 4, I get 2 over 3. Okay. So now it says, what is the scale factor of triangle DEF to triangle ABC? So if I go backwards, so starting at DEF first, which is 12, I'm going to use the same side. For 8, simplify that, I'm going to get 3 over 2. And then it says, what's the ratio of the perimeter of triangle DEF to triangle ABC? So triangle DEF, if you add up all the sides, you get 20, 30, 40, 47, 48. Okay, and if I add up all of the sides here, I get 10, 20, 28, 29, 30, 31, 32. Simplify that. If I simplify that, I get 3 halves. And you should notice that these are the same. Okay, and order does matter in all of this. So as we continue through our notes, this is the first problem we went over today in class together. So it said write a similarity statement for the triangles above. That's where the triangle ABC is similar to triangle DEF came in. Order does matter there. We did this one together. What I would like you to do is go ahead and pause and try number 2 and number 3, finding angles and sides. Okay, so looking at number 2, this is the setup I have so far. I pulled this just straight from the letters X, Y, Y, Z. So I went X, Y, Y, Z, and then Z, X. So I'm going to do the same here. R, Y, Y, S, and S, R. So there is all of my statements there. The next one is a quadrilateral. I'm going to go ahead and pause again. Hopefully you've got it all matched up already. And then I will resume when I've got it all filled in. This one, yes, you will have 4 statements here, and that is okay. Okay, so you can go ahead and check number 3. Pause it if you need to. So finding side lengths using proportions. So we did number 5 together in class. It says in the figures below, or if the figures below are similar with a scale factor of 2/3, we're going to find the value of x. So again, we're going to set up a proportion to solve. We're going to use our scale factor, okay, as our first thing, and then we'll set up our new pieces there. It's 2/3, and then the 2 is smaller, so we're going to go 42 on top with the smaller 2 on top, because I'm going to go small on top, big on the bottom. Cross multiply, I get 2x equals 126. Divide both sides by 2. I'm going to get x is equal to 63. Okay, so I would like you to pause and try number 6 on your own, and then I will come back on. Okay, so here's number 6, x equals 35. So when I set it up, I use my sides here, AB being matched with DE, and then BC being matched with EF according to my things here. And I set it up. I actually started with my big triangle on top, so this is triangle ABC on top, and then triangle DEF is on bottom, and when I say that, it goes all the way across for that triangle. So the X and the 28 both came from triangle ABC. The 25 and the 20 all came from triangle DEF. Okay, 7 we're going to save and do in class, at the beginning of class soon. Let's go ahead and look at 8. I want you to pause it and get everything matched up. I suggest that you color code or mark, or just set up your ratios would be great. So go ahead and pause and try. Okay, so here's my setup for solving for y. Doesn't matter if you solve for x or y first. So I'm going to go ahead and pause it and finish solving through, which you should also do. Okay, so on this one I got y equals 23.3 and x equals 20. Number 9 we did in class together. It's on here. So if you weren't here, need some assistance with it, let us know. Number 10, let's go ahead and do number 10. What I would like you to do is go ahead and set up number 10, and then I will come back on and help you. Okay, with this problem, here's the setup. So check to see how you did with that. If you didn't get it, pause it, but I'm going to keep moving here. Remember, if there's more than one term, I recommend that you put it in parentheses, because now we're going to cross multiply. So I'm going to multiply across this way first. So 32 times x plus 6 equals 36 times x plus 3. Distribute, so I get 32x plus 192 equals 36x plus distribute 108. Now from here, I'm going to go ahead and I want to move my x's to the right because I want it to be positive and I can see that. You can move it to the left, it's just going to be negative. At first, it'll work itself out. So I get here, I subtract 108 from both sides. Fortunately, I write pretty big, so let me have to go down. We will be doing this problem number 11 later, so try not to take up too much space here. 84 divided by 4, x is equal to 21. Said find the value of x, did that. Number 11, we're going to save. Number 12. So again, I'd like to see you set this up. Use the highlighter. You need to write this, first of all, you need to write this in place. BR is this whole side, which is 4x plus 7. BG, which is this whole side, is 18. And we're going to find the value of x. So set it up. All right, there is your setup. So now we're going to cross multiply again. Put this in parentheses. I'm going to start with 8 times 4x plus 7 equals 12 times 18, which is 216. Distribute 32x plus 56 equals 216. Subtract 56 from both sides. 32x equals, so I can reach it, 160. Divide by 32. X is equal to 5. This is find the value of x. I did that. Okay, so we'll finish those other problems together in class.